Welcome everyone. Welcome from Madison, Wisconsin here. I'm Kevin Ripp, aka the Bug Man. With me is Deborah Lee. She's our microbiologist, developer of many of our products, and Joshua Poland, who is our technical service advisor. And today we're going to talk about some of the work we do in our lab about new methods for biosolids and Lagoon sludge reduction. If you have any questions during this time, you can just chat in the chat bar. We'll go ahead and answer them. If you have questions on any of the products we referred to or anything like that, you can go into the handouts and refer to that. The materials provided talk about our Sludge Rx, which is a tablet technology, our Sludge Reducer, our Qwik-Zyme D, and a couple of case studies. As we said, those handouts are available in the upper right-hand corner. We are located in the University of Wisconsin Research Park, and we are passionate about wastewater biology. We study biology in all its forms, all the different families in wastewater, how they affect settling, sludge production, odors, nitrification, everything. We dig deep into wastewater and work to understand things that are unknown. We push the envelope in terms of wastewater knowledge. Today we're going to be talking about wastewater treatment plants, where we help our customers reduce sludge hauling and improve dewatering, and in lagoons, where we help reduce lagoon sludge accumulation. Deborah will show you how we tested that in the lab. In many communities today, we pay dearly for hauling sludge. And we're going to talk to you about how we look at that and how we work with cities in helping minimizing sludge hauling. It begins at the head of the plant. Here is a step screen or a bar screen that's at a local community. Step screens, bar screen do a great job, and there's a lot of different designs, and they all do the same thing in a different way. They remove the big solids, the big chunks of grease, the big chunks of paper, anything like that. They remove it. They do a really good job removing it. The limitations of bar screen, there's a lot of molecular forms of chemistry that pass through there. Many of those molecular forms, we would call them insoluble BOD. So they're a source of carbon, they're a source of BOD, but the bacteria can't access them. Examples of those would be fats, different protein compounds. Proteins are very stable. If you run a cheese plant, or you have a cheese plant in town, or you have a meat processor or something like that, those molecules are very stable. And then a lot of fibers pass through. You wouldn't think so, but you think, I've got a great bar screen here, no fibers are going to come through. And people say, how can I get plant fibers in my wastewater plant? And the answer is, it's called a garbage disposal. When you get hundreds of garbage disposals grinding stuff up, the molecular forms of those insoluble BODs pass through into the plant. This is an example from this bar screen. This is what we saw under the microscope. These are 2 grease droplets. Now, it's not that big of a deal, but what happens is the filamentous bacteria tend to prefer the grease. They access them faster. And if you have a large amount of grease, it can blind the filter press or affect pore settling, foaming, a bunch of things. We look at healthy floc. So what is healthy floc? Healthy floc looks like this. It's kind of evenly colored. It's really dense. The supernate is really clear. This floc here is going to settle really well. It's going to produce a clear effluent. When it goes into the aerobic sludge storage tank, it's going to settle well, or when it goes to a bell press, it's going to dewater really well. As you can see, it's very similar color, clear effluent. This is a really good example of a good floc, a good mixed liquor. When we dig deep, we're talking about taking a look at what's going on in that biology. And your biomass is essentially your floc. Your floc is a collection of all the floc together, your biomass. When we look at floc, we look under, this is called fish microscopy, fluorescent microscopy. We want to know what's going on. And there's 3 areas that we really work on here. 1, we look at the percentage of live bacteria in the floc. In this example here, the red stain you see, that is dead bacteria. And the green bacteria is the living bacteria. In general, about 10 to 30% of your floc is live bacteria. And most of the time, it's 10 to 20, really. That percentage of live bacteria is what's responsible for the metabolic processes in your plant, for removing ammonia, phosphate, nitrogen, clarifying the water, everything. The remaining 70-90% of the floc is dead bacteria, or EPS. EPS, you'll hear us talk about a lot. That's the extracellular polymeric substances. It's the glue that bacteria produce that allow the floc to stick together, form a dense floc, and settle and dewater well. In general, live bacteria dewater better than dead bacteria. So when we get a better percentage of live bacteria, they dewater better. When we get a higher percentage of EPS, they don't dewater as well. The last part of that is undegraded organics and inorganics. The undegraded organics are what we're talking, that's the insoluble BOD. It's BOD that could be available for the bacteria, but the bacteria aren't going to be able to break it down. That's things like papers and greases and things like that. If you break that down, it's a rich source of carbon. If not, it'll just pass through your system into the end. The aerobic bacteria will not be able to break this stuff down. And like we said, not all bacteria dewater well. There's a lot of different families of bacteria in your mixed liquor. Let's say you have 10 different families, and those families shift between the winter and the summer. Some of those families don't dewater well. Sulfate-reducing organisms, iron-reducing organisms, all those kind of things, they don't dewater well. So we always look at the community and try to balance the community. When people say, I think I'm hauling too much sludge or my belt press isn't dewatering well, we always go back to the front of the plant and we say, what's going on in your process? We might look at your DO. Sometimes in the middle of the summer, you can get low DO, which can bring on sulfide filaments. Sometimes it's a nutrient balance. Maybe you have an industry in town that puts waste into your process and it throws off your carbon to nitrogen to phosphorus ratio. Other times it's a function of organic loading. Some municipal plants are vastly over-designed and they don't get enough food in there to really sustain good things. And some industrial plants are very under-designed. And so sometimes it's a function of organic loading. It all comes down to the back end of the plant where this is the belt press. And if you get excess fat, oil, and grease, it won't dewater as well. If you get a lot of papers, fibers in your mixed liquor, that won't dewater as well either. But the fibers hold on to water. Give you an idea, a piece of paper or tissue, which you may see in your mixed liquor, will hold up to about 20 times its weight in water. So if you break that down into a bunch of carbon, the carbon stimulates the biology, and then you're going to dewater better. So if you break that down, you can release a lot of that water. So here we're talking about dewatering and sludge accumulation, and this is a picture of floc, and those are paper fibers. Sometimes people look at those fibers and they think they're filaments, but they're not. They're too wide and they're too long to be filaments. They're paper fibers. And this is from the place where we had the picture of the bar screen earlier. So they're common in almost every wastewater plant. We get samples in from around the country. People use our lab services to help us identify and understand exactly what's going on with their process. It's very common to see those fibers. And products like our Qwik-Zyme D, which Josh will talk about, we put that on a metering pump, we meter it into the plant, and it degrades that and releases all that water. So that paper you see there is what we call insoluble BOD. It's a source of BOD, but the aerobic bacteria aren't going to be able to access that unless we break it down. One of the other things that causes problems is this extracellular polymeric substance. We talk about this as being the glue that holds bacteria together. In this example is an example of a slime bacteria called Zubliel. If you get this sliming, it will slime all over your belt press. And you'll have a mixed liquor and you'll say it's not settling, but I don't see a lot of filaments, but it's not settling. That's an indication that you're sliming. We just call it sliming, for lack of a better word. But it's caused by a nutrient imbalance in your process. And so those are the areas we look at when we work with people to help reduce solids in a wastewater plant. And it's really easily doable. Next, we go to Deborah, who's going to talk about wastewater lagoons and how we go about testing and treating sludge in wastewater.
All right. Well, thank you. First, we're going to do a quick poll. So if everyone could switch over to your poll tab and answer that. Looks like it's pretty even between whether you've sludge judged your entire lagoon or not. So this picture here is just one of our sales guys out in a boat attempting to do a sludge judge on a lagoon. So I can fully understand if you have not sludge judged the lagoon. It does require a boat, a sludge judge, and a lot of time, possibly another person to help keep the boat steady. The sludge judge is a really good way to determine how much volume of sludge you have in your lagoon, but also how much water you might still have over that sludge. So in effect, it can help you gauge whether you're losing water capacity or retention time in your lagoon. So it's a very good method to use just to see how long will your lagoon perhaps keep performing well. So I'm going to go over today how we study our Sludge Rx product in the lab and what our major findings are when we do these studies. We've done Sludge Rx studies in the lab for a few years now, and we do keep getting pretty consistent results, which does seem to be applicable to in the field as well, from what we've heard from operators who have used the Sludge Rx product. So starting off in the lab, we just take a standard 15-gallon aquarium tank. On the bottom of that, we put in some washed sand, cap that with a thin layer of clay, just like most lagoons are. And then you take some of your sludge from the field, a lagoon. So if you have a lot of sludge in your lagoon, this is great. You can just haul it in real quick, screen it through one of those cookie cutter screens, and just start up your tank studies. We also fill up the water from the same lagoon that we took the sludge from, and to a certain height over it. What we do with Sludge Rx is, because this is such a small volume or square area space to use, we actually have to break the tablet up, but still make sure it sinks in our random spread out areas. So we cut them up, throw the chunks out there, watch them all sink down, and then we do several measurements every week or every other week, depending on how the testing is set up to go. So one thing we do is we measure it like a sludge judge. We actually just take a straw where we've marked off different centimeter lines. And if you see on that bottom right-hand picture there, you can push your straw down to get your water volume, and then push it down further to get your soft sediment layer. And in that way, you can judge if you're getting any sort of soft sediment reduction. We generally set up a grid on top of it, on top of the tanks when we do this, just so we can measure a lot of points. Usually we have about 30 to 32 areas that we measure. And the testing will happen every week or every other week, as I mentioned. Before you actually do the sediment measurements, though, we do take some of the water off to do some water quality analysis on it. Now we're going to go into some of the major findings that we see when we use Sludge Rx. We actually see one of the major things is soft sediment will reduce when you apply Sludge Rx compared to the control tanks. Another way to test that is looking at total volatile solids in your remaining muck. So total volatile solids is generally taken as an approximation of how much organic matter you still have. We see in the control tanks, which is that top picture there, you end up with a lot of total volatile solids still remaining in the tank and not much total solids in general. So when you have that sort of ratio of high total volatile solids, low total solids, you end up with kind of the slimy, squishy, kind of gelatinous layer on top of there, which is probably a bunch of those polymers just not breaking down or getting otherwise utilized. What also happens is those polymers like to bind water. And when it binds water, it just kind of increases your sludge volume. They kind of puff up a little. So that might also impact dewatering in the case of sediment reduction. What we see in the bottom tank is when you treat it over an extended time with Sludge Rx, you actually see a reduction in your total volatile solids and a corresponding increase in the percentage of total solids that you have, which is good because it means a lot of your organics is generally being metabolized, reduced, otherwise no longer present in your sediment layer. So what happens with the lower total volatile solids is those sediment particles tend to compact very densely, and they end up kind of squishing down in the bottom, and you see that sediment reduction. So another thing that we've noticed many times in the lab is if you look really closely at the sediment layer, you'll actually start to see a biofilm layer start to grow across the tops of the sediments in the tanks treated with Sludge Rx. Now this is very useful because when you have water movement from wave action or boats or animals, you normally get a lot of sediment resuspension. And when that happens, it actually has a corresponding release of nutrients from within the sediments. So if you have a lot of sediment resuspension, you'll get a lot of nitrogen and phosphorus going into your water column, and then subsequently into your effluent, which is not good. So with Sludge Rx treatments, you see your sediments kind of stabilize due to that biofilm, and not so much resuspensions, not as much release of nitrogen and phosphorus into the water. So another thing that biofilm layer helps with is actually improving your water clarity. These two pictures of the tanks on the right here, the Sludge Rx and the control tank, were actually taken at the same time near the end of the tank study treatment. So the Sludge Rx tank had remained clear the entire time as it was being treated with Sludge Rx. However, the control tank was not. It started off slightly cloudy and then ended up very cloudy. Besides visually measuring that, we can actually measure it very accurately using the spectrophotometer. So in that graph there, you see our optical density at 580 nanometers, which is a very good wavelength to check for bacteria. The control had more bacteria than the Sludge Rx. We also looked at optical density 681 nanometers, which is very good wavelength for chlorophyll A, which is an algae. So the control tank also had more algae present in the water column than the tanks treated with Sludge Rx. Real quick, I'm just gonna force another poll on you guys, so if you could just please answer that quickly. All right, so we are seeing some people have had some algae blooms. That's pretty common, considering these are wastewater plants. Your primary purpose is to collect and treat that nutrients so it can't get out into the environment. So yes, you're retaining the nutrients. So what happens a lot of times is if you do have an algal bloom, it's going to bloom, make your water kind of cloudy, make your TSS levels go up, but eventually it's going to crash and it's all going to settle down to the bottom into that sludge layer. What happens there is algae is actually pretty easy for bacteria to break down. And when they break them down, it has this release of nitrogen and phosphorus. Even if it doesn't get used or utilized very quickly, that nitrogen and phosphorus is still present and will remain present in your sludge layer. So when we look at our tank studies, when we look at the sludge at the end of the study, we like to see the total nitrogen and total phosphorus amounts. What we generally see is we see a reduction in total phosphorus in the sediments of tanks treated with Sludge Rx, but not in the control tanks. The total nitrogen also does go down a little bit. It's a kind of a corresponding along with bacterial metabolism. But what's important for algae is not only how much phosphorus you have, but also the ratio of nitrogen phosphorus. You want to have that ratio be pretty high by reducing phosphorus, not necessarily by increasing nitrogen. But what happens when you have that high nitrogen, low phosphorus is you end up mostly with green algae, which is better for the environment because they don't produce toxins and they're a little easier to digest than cyanobacteria, the blue-green algae. So cyanobacteria will bloom when you have lower nitrogen and higher phosphorus. So that's why reducing phosphorus is important, especially within the sediments of a lagoon. So something of concern, because we are dealing with wastewater here, is does this introduce pathogens? Does it change the environment in a way that lets pathogens propagate? So to answer these questions, we take that sediment at the end of our tank testing and we send it out for a 16S rRNA analysis. And that will give you generally your list of bacteria that's inside the sediments. We do screen it a little bit, just hitting known pathogens that are out there. And generally we don't find any pathogens in our tank studies. And as far as we know, no one's noticed anything like an increase of E. coli when they use these products in their lagoon. What we do see is that with Sludge Rx, your bacterial population changes into a way that signifies you're getting more complete digestion of your organic matter. And when I say this, it's most of your digestion is going to happen anaerobically within your lagoon sludge. So you start off with your organics in their natural form. Those get broken down to acid, or some sort of acid generation happens. That gets converted into acetate, and then the acetate gets converted into methane. Looking at that last group of organisms, the methane generators or methanogens, we can see how far along some of these sludges that we treat might be. And generally, every time we look at these bacterial populations, we do see that tanks treated with Sludge Rx not only have a lower total volatile solid content, but also have an increased population of methanogens compared to the control tanks. So to sum up our findings on Sludge Rx, first, using Sludge Rx will reduce your total volatile solids, which can be an estimate of your organic content in sludge by degrading your complex organic compounds. Sludge Rx will also create a biofilm over the surface of the sludge that lowers your total solids, or your effluent total suspended solids, and also stops the resuspension and release of nutrients into that effluent. And lastly, Sludge Rx will speed up the bacterial degradation of organic matter without introducing pathogens.
So now that everyone is a little more familiar with how and why these products work and how we develop them, I'm going to talk a little bit more about whether they're right for your treatment process, how to dose them, and some of the field data we've collected in some of our case studies. So to continue our conversation about Sludge Rx, when is this product going to be right for you? So almost all lagoons can benefit from some biological additives, but if you have a large amount of settled sludge or have noticed a downward trend in your effluent water quality, Sludge Rx could definitely help. If if you've done a sludge judge, or if you know that your volatile solids percentage is over 10%, this is going to be a really strong contender to help improve your capacity of your lagoon overall. For dosing, we recommend around 30 to 60 pounds of Sludge Rx spread evenly across your lagoon per acre. For best results, we recommend dosing as soon as your water tap is above 50 degrees. Kind of take advantage of those higher temperatures and higher biological activity that comes in the summer months. We've got some case study data. This is taken from Sparta, Georgia. We did this last year. If you can kind of look from left to right, the black line shows a reduction in sludge over time in feet. So over the entire treatment, we reduced to around 2 feet total average reduction across their 2-acre lagoon, which is about 20% of their total capacity regained from the Sludge Rx treatment. Additionally, Town of Sparta was quoted for around $500,000 for the dredging and disposal of their lagoon sludge. Sludge Rx was able to increase their capacity, their retention time, and overall improve their nutrient removal at a fraction of the cost. And again, this study, the full study, is in the handouts section of the page if you want to learn more about it or how some of we collected some of the other data points. Talk a little bit about Sludge Reducer. Now, if you've recently dredged or removed the majority of organics in your system through biological reduction, like Sludge Rx, there's still a good reason to continue adding biologicals to your system. VitaStimSludge Reducer introduces micronutrients and biodiversity to your system that will remove these incoming organics and would otherwise settle out in your system to improve your long-term lagoon capacity and performance over time. We recommend adding around a ½ pound of Sludge Reducer a day per acre lagoon that you have in your treatment process. What is the difference between Sludge Reducer and Sludge Rx? That's a great question. They are similar in that they are both biological additives, but Sludge Rx is in a dense pellet form so that it sinks down into sludge, whereas Sludge Reducer is in a soluble packet. It's a little bit easier to use, and we use VitaStimSludge Reducer as a maintenance tool over time that you can add daily, whereas Sludge Rx is kind of a heavier dose that's going to remove a lot of organic solids throughout. So this is more for clarifying the water column and just introducing some extra bacteria to remove organics. Let's see, I've got from Clint, I did a lagoon treatment last year. What benefit would I get from treating again? So again, like adding additional organics over time is going to reduce these incoming nutrients, prevent buildup, and just maintain your lagoon's ability to treat water effectively, reduce the chances of getting nutrient spikes throughout your system and just lowering that average effluent quality. Away from the lagoons a little bit, over to the wastewater treatment plant side with Qwik-Zyme D. Qwik-Zyme D is a biocatalyst that Kevin touched on a little bit earlier. The goal of this is to break down insoluble BOD and other dewatering inhibitors that would prevent your process from consolidating organic solids. This is for anyone who's looking to improve their belt press, centrifuge, or aerobic digester in general. By breaking down these inhibitors, we're able to improve the efficiency of your process in a number of ways, like cutting costs on polymers and sludge hauling, and what's applicable to you guys, up to about 30%. For Qwik-Zyme D, we're recommending a dosing of about a ½ gallon per day per 100,000 gallons of flow for at least 60 days to see effects over the long term. From left to right, this is a case study that we did in a municipality in Illinois. On the left-hand side, we've got the cost of polymer per ton of organics that they were removing. They reduced that by about almost 20%. Then we've got sludge hauling. This is reducing the volume of sludge that they were hauling by about 10%. And then they were able to improve their percent cake solids by about 1%. And all of these actions all at once were able to save them thousands of dollars per year in total sludge-related costs. Yeah, and with that kind of concludes the main portion of the presentation at this time. I'd love to answer any questions that you guys have. Does the degradation of sludge cause an increase in ammonia or phosphorus in the decant? Deb, Kevin, you guys want to take this one?
From what I've seen in the lab, no. Doing degradation in the sludge with Sludge Rx particularly does not really affect the water quality other than increasing clarity and maybe decreasing a little bit the ammonia and phosphorus that would have gotten released with resuspension into the water column.
I did a lagoon treatment last year. What would be the benefit of trending again this year? I think the benefit of ongoing thing is we keep the microbial diversity in the microbial populations high. We keep them high, we keep the sludge low, and as we attack stuff on the bottom of the pond, all the algae in your pond comes from the bottom. It all originates from the bottom. And that was one thing that Deborah touched on with the Sludge Rx, is when we put bacteria on the bottom of that pond, it fixates the nutrients and allows that water above it to naturally clarify. Okay, because we're starting the process at the bottom. The other thing I wanted to mention, Josh was talking about that Qwik-Zyme D study. That is a relatively brand new plant. It's a brand new plant, and it's got the latest in everything. And they still saw reductions. They still saw reductions because there's lots of insoluble BODs that we're able to.
Kind of continuing the conversation on Qwik-Zyme D, how quickly can I see results? In an aerobic digester, you might see some improvements in settling and decanting after about 30 days, but we do recommend for about 60 days to see kind of the full results of breaking down these things and seeing an improvement over time, as it is just percentages of insoluble BOD that you're removing. It can take some time to kind of see the full results of how effective they are.
And I wanted to add, as I said in the beginning, we're fundamentally a lab. So if you get something strange or unusual that comes into your process, feel to reach out or to send us a sample. We can identify it, whether it's a bacteria or an algae, we can identify it. And then from the identification, we can know what drives it. What is driving? What is causing this? And then we work hard to reduce the root causes of a problem.
Right, so we got another question. Does Sludge Rx reduce algae as well? Well, Sludge Rx does not directly attack algae or really alter it in any way. What it does do is reduce the nutrients that the algae will feed on. So if you don't have as much nutrients for algae to grow with, you probably won't get as much growth of algae. And you dose Sludge Rx to the pond influent flow. Our pond has less than 1 day turnover. I don't think I've ever been asked that before.
Yeah, it's a fast turnover.
Yeah.
That pond goes over fast. I would think yes, because it's Sludge Rx goes to the bottom of the pond. The water flows over the top, and the pond, less than 1 day turnover. Boy, that is fast.
Yeah.
What causes odors in my lagoon? So in a lagoon, there's turnover every year. We come out of winter, and and then that heavy water goes to the bottom, and it turns over, and that reduces the odors. So there's two things. One is you reduce sludge. Okay, you reduce the amount of sludge, you reduce the amount of water. The second simple thing is just keep a lot of water in your pond. If you keep a lot of water over your sludge layer, the odors are generally less. But do as good as you can degrading all those solids, and then keep a good layer of water. When I see lagoons and the water level gets too low, then we can start to see more odors in general, not always.
How should I go about treating my lagoons when they freeze over, particularly in Wisconsin? It's tricky. We have heard some people where they try to poke a hole in the ice and treat it that way. We usually recommend waiting until the spring when it thaws out, when your biology has a chance to really get to work, and treating it as soon as that ice thaws. As soon as you get to about 40 degrees, that's when you can really start using biological additives to start helping your lagoon.
And someone had asked, how does our product compare? So we get samples of all of our competitors' products, and Deborah monitors growth rates of all the products. And so with all the different products, we have growth rates. What's key in a bacteria is how well does it grow? Okay, you can add it, But bacteria do this thing called quorum sensing, where they communicate and they communicate with each other, and they talk to each other, all these different families. So one of the things Josh talked about earlier is creating biological diversity. We want to create diversity in a waterway, but we have data on all these different products, and we measure it in terms of growth rate. How well does the product grow 7 days from now, 14 days from now? How well does it grow, and how well does it sustain?
How much VitaStim should be added to a 300,000 gallon oxidation ditch, and with what frequency? I mean, you could add VitaStim Sludge Reducer to that, but I would probably recommend something like VitaStim Rebuild in this sort of situation. Forget the exact dose rate for Rebuild in a oxidation ditch.
Yeah.
Now, if you do have settled sludge built up within your oxidation ditch, we have used something like Sludge Rx to break down individual buildups within your ditch, whether you've got like a nook or a water is channeling sediment to a specific location for whatever reason, or below your diffusers. You can use that to break down that settled sludge and kind of improve the efficiency of your system a little bit. What Sludge Rx impact downstream mechanical treatment process that rely on the volatile fraction of solids leaving the lagoon for biological treatment?
Sludge Rx, Deborah, you might be able to add a little more depth to this, but Sludge Rx is going to break stuff down. There's no doubt about it. If your volatile content is higher, we're going to lower that volatile content. I guess it depends on what your downstream biological processes are. But generally, we're going to break down things into more elemental products and create more diversity in that pond, and then help to lower nitrogen, phosphorus. It really depends on what your downstream treatment is you're referring to. They have a sludge. We have a 3-pond system. Would we test sludge in all 3 ponds? Josh, want to answer?
Yeah, I mean, you definitely could sludge judge in all of them, but I mean, typically we recommend in the primary pond, or that first influent pond. That's going to be the most important, because that's going to be the one that's going to be retaining most of the nutrients. You could go into the secondary pond, but typically that first one is the one that's collecting a lot of that sediment, and it's going to be the most important.
And we always say, treat the first one, the second and third one will take care of themselves. Not that you don't do treatment on the second and third, but the bacteria from the first one are going to repopulate in the second one and the third one. They're going to go downstream. And reducing ammonia quickly, that's a tricky answer, especially depending on your climate. We use our Sludge Rx to lower it, and we have a lot of data, but you're not going to lower it 90%. Maybe you can lower it 10 or 15% a year, but you're not going to go from 33 parts per million down to 3 ammonia, something like that. But usually we fixate everything in the bottom. The more carbon we create in the bottom, the more nitrogen when we break down that insoluble BOD into BOD carbon, we consume more nitrogen and phosphorus in that process, and that helps to lower the nitrogen. But sometimes the cold temperature of lagoons is very limiting.
Will Qwik-Zyme D help in the digester to make it possible to siphon off clear water? So yeah, this is one of the key benefits for Qwik-Zyme D in aerobic digesters, is to help improve that settling and improve that decant, so that you can move through and dewater a little bit more effectively. And we've seen some good results out of that. We have a number of customers who are using it for that exact reason right now. Would you suggest adding the Sludge Rx to the aeration basin ahead of the tertiary pond? How would it affect the overall biology of the aeration basin? Just answered part of this question. How would the effect of the biology of the primary pond aeration basin? Okay. If it's an aerated pond or an aeration basin, this is definitely where you would add Sludge Rx. This is where it's going to be, the biology is going to be most active. You're going to be adding an additional biology. So, I mean, we're going to have increased biodiversity. You're going to have increased micronutrients that are going to help that biology to degrade organics. And it's overall going to improve the ecology of that aeration basin to remove organics.
And sometimes in an aeration basin, if you have an oxid or just a regular biological process. In an aeration basin, underneath the aerators, you can get sludge building up. And that's a good application for Sludge Rx. We put it, it gets underneath the aerations, it reduces that sludge into the corners and stuff like that. Can I do a microanalysis? Yeah, and that's what Deborah does a lot of. Deborah has a unique skill set. She can not only identify bacteria cultures, but she can identify algae cultures, which she often says is more complicated than identifying bacteria. So we do a lot of that for lagoons, just to know exactly what is going on, exactly the species and that kind of thing. And I can talk all days about algae because they're really, really fascinating. And so it's very important we know exactly what the algae is, so we have data on it.
See, Ryan, what are the main differences between Qwik-Zyme D and bug juice in regards to sludge reduction? Qwik-Zyme D is the successor to bug juice. Throughout our development process, we're always refining our products and reformulating them. And Qwik-Zyme D is the enhanced version of bug juice. And same, if not better, reduction in terms of sludge. Can we send you a sample of our sludge? Absolutely. Just let us know that it's coming. That's the best indicator for all of our lab samples. Would you make any adjustments to the Sludge Rx to fine tune it in our system, or is it the same product for all ponds?
Sometimes, depending on what we find, we might put in some Qwik-Zyme D with it in your treatment, stuff like that. If we find a lot of insoluble BOD, that kind of thing, and we could adjust the dose rates or that kind of thing. But sometimes it isn't bad to have that number. We can see the volatile portion, and we can give you a good estimate as to what you're going to see.
Tom has a good question here. Does Sludge Reducer or Sludge Rx work well in anaerobic biosolids basins where they need aeration to be effective? Strongly recommend aerated zones for both of these products. I'm not sure how effective either of these products would be in an anaerobic zone.
Yeah, in an anaerobic zone, we have a separate group of products that work better under those conditions.
Yeah, for organic sludge reduction, having oxygen is incredibly beneficial. The amount of biological activity is like 18 times in an oxidated zone versus an anaerobic zone. Bacteria in my sludge accept help with midgefly or redworm mitigation. Potentially, reducing their habitat and the organics that they're consuming could have an effect on their overall population, but we'd probably recommend something like Aquafix to start targeting those redworms specifically. But general reduction in sludge will kind of reduce their want to be there because that's their primary food source. So marginally, I guess would be the answer there.
Keep in mind, the redworms are there to eat your bacteria. They're there to eat your biomass, so that's why we want to use our Aquafix. And coming out advanced treatments like integrated fixed film wastewater for biologic treatment using aerobic aeration cycles. Deborah, you might be able to comment better on that.
Okay, so the question is, it seems most of your studies are related to lagoons. Can you comment on advanced treatment systems like integrated fixed film wastewater treatment, also using aerobic aeration cycles with DO control, and how you would use any of your products in this advanced treatment scenario? Will your products reduce biosolids production in an advanced wastewater treatment facility? We have products that will do such things. Sludge Rx is mainly situated for working on the bottom of unsophisticated systems, let's just say it. And that's mostly because in lagoons, you don't have a lot of agitation as you would in more conventional wastewater treatment plants, and certainly nothing like fixed film. So what happens is all the solids and floc you would have generated go straight to the bottom and stay there because there's no mechanism to resuspend them again or otherwise really recirculate them or get them out of the system. But yes, if you'd like to know about using some bacterial products in fixed film wastewater treatment or other more advanced wastewater treatment systems, you can certainly email us and we can maybe go through what exactly you're looking for and provide some recommendations.
I would say on the fixed film, if you got an MMBR or any kind of like that, the biggest problem we have with those is grease builds up on the film. And then we get foaming problems. That's the biggest thing. And maybe you have a system, you don't have a system, you don't have a problem, and that's fabulous. But I think the the general thing is no matter what you do, if you get paper and grease in there, generally speaking, the bacteria aren't going to break it down. There are some cases where they can, but they're not.
That's some further clarification on my first question. Specifically, nitrification and bio-P that rely on volatile fractions of the biomass within an activated sludge system. Being fed with an anaerobic lagoon pretreatment, assuming further volatile degradation in the lagoon feeding the activated sludge plant. This would lend to one potentially having to run a longer sludge age in order to carry the same fraction of volatile biomass. Deb, you're shaking your head a lot.
I understand now.
Yeah.
That makes more sense to ask that.
Yeah.
Yes, so in that case, I would not focus on using Sludge Rx in your anaerobic lagoon, which is ahead of your bio-P system. I would maybe not really use it unless you were specifically having problems with channeling in that upstream anaerobic lagoon. And channeling is just sludge filling in, so your water ends up flowing through faster.
I've got another question. My effluent numbers are good. Why should I treat my lagoon? Because you've always got incoming organics and incoming nutrients, and adding an additional biomass is going to help retain your lagoon's capacity and its ability to treat water effectively. So, you're going to always kind of be fighting against incoming organics. You're going to need to do something about that. Otherwise, they will just settle out and slowly build up over time, and that's going to have negative effects on you in the long run.
And I should say too, we do, as you know, we do a lot of micro analysis for wastewater customers. We look at their bacteria under the microscope and kind of go a level or two deeper beyond what they're able to do in their lab. But one of the things we always says, it's always good to do that if we can when the plant's running really good. So we know what it looks like when it's running good. As you guys know, as wastewater operators, every day changes. Every day is a new day. And so it's running good. That means it's running good today. It doesn't necessarily mean it's going to be run good tomorrow. So we're always trying to be proactive and look ahead and see what's coming down.
See, looks like we got a couple time for a little more. Where should I dose Sludge Reducer into my lagoon? Should I dose in different places every day? Yeah, we typically recommend adding them in different locations, but again, we're going to be adding this close to the influent of that first lagoon, but because that's where most of your biosolids are going to settle out is right in front of that influent pipe. So that's where I would dose that to get the best effect out of that. Let's see what happens to the solids when you do a biological treatment. A lot of organic solids are pretty voluminous they're degraded through biological additives. They're going to be condensed and reduced. Nutrients are going to get either, nitrogen is going to get floated up out of the water column. Phosphorus is going to get bound to cells and things like that. So it's going to be removed and condensed into cell mass.
Thank you all for attending. Thank you for being part of this, and we really enjoy each one of you. And just thank you for being part of this. Hope you got something out of it, and always challenge us. Thank you.